Alright guys, welcome back to Underground Science. In this video we're going to continue talking about oxymercuration, demurcuration. We're mainly going to be focusing on the fact that this reaction is anti-addition, which we didn't really talk about in the last few videos. Alright, so let's go and get started. So from our previous video we remember this example, right? We're not going to go into the mechanism of how this works because we already did, but we're going to focus on the fact that this reaction, right, oxymerc and demurc, is anti-addition. Okay, and so in a previous video, we've gone over what syn addition means. In this video specifically, right, we're going to try to focus on what anti-addition is. And syn addition is basically adding to the same side. So anti, which is pretty easy to guess, is adding on opposite sides. The reason for that is because if you remember, we have our mercurinium ion intermediate, right, in oxymerc-demurc reaction. And so you remember how water comes and attacks the more substituted carbon, because this is secondary, this carbon's primary. And so when water attacks that carbon, there's two possible states that I like to think of this. Okay, so first I draw this intermediate, and second I draw this possibility. Right, first, either this mercurinium ion can be faced towards us in 3D, if we're talking about 3D structures, right? It can be faced towards us or up, right? If you want to think about it like that, because it's on a wedge. Or the other option is, when you form this intermediate, this mercurinium ion could be faced away from us. Okay, so knowing those two options, when water comes and attacks, if this carbon is wedge bonded to this mercury acetate compound, right, you can't attack this from the top. Like let's say in this case, wedge means top. Both these carbons are wedged to this mercury acetate compound, right? So if water is coming here attacking carbon, it can't attack from the top because carbon already has something bounded to the top of it, right? Because this is a wedge. So the only possibility is water attacks from the bottom, or bottom in this case we'll say is dash. So the next step to this reaction would be right here. See how water, when attacked, it ended up on the dash, because this was already on the top, so it didn't have space to attack from the top, so it attacked from the bottom, or which basically means it ended up on the dash. In terms of 3D, is going away from us, right, into the screen. So next what happens, we said the acetate comes in and takes the hydrogen away and makes the OH, right? And the next step after that is reduction or demurcuration with sodium borohydride. So basically this would lead to this product, right? But if we drew the 3D in, right, the 3D structures, we're only focusing on what the OH looks like. And so the OH in this case is dash, right? So it looks like this. And if we look at the other possibility, right? So again, this was dashed, right? So let's say dash in this case means bottom. If this carbon right here is already bound to this mercury acetate complex, right, and it's already on the bottom, so when water comes and attacks, it can't attack on the bottom because that space is it's not free to attack. There's something coming in the way of water attacking from the bottom, right? So we'll go over steric hindrance in a future video, but you can think of it kind of like that, is the space is already taken up on the bottom for this carbon because it's already bound in terms of a dash bond, right, to this mercury acetate compound. So the only way water can attack this carbon is from the top, so a wedge bond, because again, the bottom's already too crowded. You can think of it like that. So when it does that, it becomes on a wedge bond, right? And after you do demurcuration with sodium borohydride, right, reduction, reduce this carbon right here and put a hydrogen, we're going to end up with the other possibility, which is like this, bound to the hydrogen. And then the main thing we have to say is, okay, this is on a dash, OH. So if we notice here, one possibility is there, one possibility is there. Okay, these are our two possible products that we can get from this oxymerc-demurc reaction. And the anti part comes right here. So the anti part comes right here and right here. Because notice these two bonds are on the opposite sides of each other. It's not on the same side. One is dash, one is wedge. One is going away from us, one is coming at us. Okay, in both cases. All right, so these are our two possible products. And that's basically it for this video. And I'll see you in our future videos where we'll talk about more reactions. I hope to see you guys there.